We will solve all the computer exercises in RStudio, and in RStudio there are four windows, four panes. This upper top window is the script file where we will write all the code, and this bottom window is the console window. It shows the output of a code, and in the right upper window it is the environment window. It shows all the objects and values created through our code, and this bottom right window shows the plots, packages, files, etc. So we do not require this right window. We can minimize this, and we can also stretch this to the minimum. Okay, so first what we have to do, we have to set the working directory. So you should create a dedicated folder in your laptop or computer. I have created a folder by the name of Econometrics in my laptop. You can create a folder in your laptop or computer by any name you like, and then set working directory. To set the working directory, type set wd function and then go to this folder and copy the path and paste it here, and replace this backward slash with forward slash and put this path in double quotes, and then press control plus enter. Alternatively, you can go to session, go to set working directory, and then choose directory, and then you can select your folder. Okay, and we can clear this. We do not require this information. Now what you have to do, you have to install two packages. First is Wooldridge. Press Ctrl plus enter and then install the package deployer. Then call these packages through library function. Press Ctrl plus enter and then call this package deployer. Press Ctrl plus enter. Now I will open the file so that we can work along with it. Yes, now it's okay. Now let's start question 1. In question 1 there is the use of the data wage 1. So call this data, name this data, and then type this package equals to Wooldridge. Remember to put this value in double quotes after package, and then press Ctrl plus enter. Now this wage 1 data object has been created. Now attach this data set so that we can call the column variables by directly naming them, and we will not use the dollar operator to use them. Now to look at the data, now look at the column headings, we can use the function head and then put the data set name. So these are the column heads. Okay, now let's look at the question 1. Find the average education in the sample. Simply we can type mean, and the education is named as ADUC in our data set, mean education. So mean education is 12.56 years per person. What are the lowest and highest years of education? We can use range function for this. Now the minimum years of education is 0 and the maximum years of education is 18 in our sample. Now look at the second question. Find the average hourly wage. Then use this mean function, and wage is named as wage. So the data set is from 1976 US dollars. So the mean wage at that time was $5.89 per hour. And does it seem high or low? Well, I think it's high. It's high. It was high at that time. Okay, now look at the third question. The wage data reported in 1976 dollars. Using the internet, find the consumer price index for the years 1976 and 2013. So the consumer price index for the year 1976 was, use the assignment operator now, 56.9. I have given the link to the website from where I have taken these values. So you can verify these values from there. Press Ctrl plus Enter, and then CPI 2013 to 33. Press Ctrl plus Enter. Now what it says, the fourth part, use the CPI values from part third to find the average hourly wage in 2013 dollars. Okay, now what we have to do, we have to find mean wage in 2013 levels. So use this formula, CPI 2013 divided by CPI 1976, and then multiplied by the mean wage of the sample. Now type this value, mean wage 2013. So the mean wage in 1976 dollars 5.89 is equivalent to $24.14 in the 2013 period, and yes, it's high per hour. On the per hour basis, it's a very good amount. Now look at this fifth part, how many women are in the sample, how many men. For this you can use the simple command called table from the base R, and the gender column is named as female. So in this column, since the column name is female, so the 1 values represent the participant as female, and the 0 values in this column represent the participants as male. Then simply type the variable name female. So here we are. In our data, 274 are males and 252 are females. Alternatively, you can also use a function from the dplyr package. Type wage1 dataset name and then use pipe operator. Type group by, and then in the bracket the gender column, which is female, and then again use pipe operator, and then type summarize, and then write the column name by which you would like to see the data. I am typing the name gender count, and then use this n function. It will count the elements by the group. So we can see the answer is same again. The female participants are 252 and the male participants are 274. So it's just a different way of calculating the same thing. Okay, now the question is done. So let's detach the data set. Remember to detach the data set once its work has been done. Okay, now let's come to the question number 2. The question number 2 utilizes the birth weight data, which is named by BWGHT in the package Wooldridge. Press Ctrl plus Enter, and now attach this data set BWGHT. Now let's look at the column headings of this data set, and let's also look at the structure of the data set. Use the command str for looking at the structure of the dataset so that we can know the nature of each variable. Okay, the head command gives you the headings of all the variables, and this structure command gives you the structure of this data, so that look at this, family income, cigarette tax, cigarette price are all in numeric form. Birth weight, father education, mother education are all in integer forms. Okay, so now let's look at the question. How many women are in the sample? Again, we can use the same simple command table, and the gender column is represented by male. So the values 1 represent the male participants and the value 0 represent a female participant. So 665 are females and 723 are males. And how many women, how many report smoking during the pregnancy? Okay, so for this we can create a new column in the data set by using the dollar operator. So the data set name is BWGHT $. Let's give it the name of women 6, women who smoke cigarettes during pregnancy, and we can use the command if else for this. Now if the male is 0, it means if it's female, then copy the values from 6, otherwise type NA. Now after doing this, after creating a new column in our dataset, we again have to attach this dataset so that we are able to call this column. Now use this function sum women 6. We want to report the women who smoke during pregnancy, therefore this value should be greater than 0. And if there are NA values in your data, then you should type an additional parameter na.rm equals to true, and true can be represented by simple capital letter T in RStudio, and then type control plus enter. Now there are 112 women who reported smoking during pregnancy. Now what is the average number of cigarettes smoked per day? Is the average a good measure of the typical women in the case? Now average number of cigarettes smoked per day. Okay, so let's use the data bwght. I'm going to use a function from dplyr package for this. Use the pipe operator. Type group by. The gender column is male. Again use the pipe operator. Now type summarize. Now write average equals to mean 6. Type na.rm because there are some na values in your data, and we can also summarize the data. Let's look at the total number of participants so that we can make a comparison. Gender count, and again total cigarettes. Create a column by the name of total cigarettes. Now look at this. The male participants are 723, and the average cigarette smoke per person is 2.08 in the male participants, and the total number of cigarette smokes are 1507, and for the female participants the average is 2.09, and the gender count is 665, and the total number of cigarette smoked by these participants is 1390. Now the average good number, a good measure of the typical women? No, it's not good, because some women do not smoke in this samples. Therefore, it's not right to consider this average. Instead, we should calculate a different average for different participants on the basis of their smoking habit. So now let's look at the third part. Among women who smoke during pregnancy, what is the average number of cigarettes smoked per day? So now it tells us to calculate the average for only those women who smoked cigarettes during pregnancy. So we can do this. We had created a column by the name of women 6, and in this parameter we can in this function we can specify that take only those values which are greater than 0, and if there are some na values in your data, then type na.rm equals to true. Now let's look at this average. The average cigarette smoke per women who smoke is 12.41. It's greater than the previous answer, because in this function, in this part, we have considered only those women who smoke during pregnancy. Okay. The next part is find the average of path education in the sample, and why are only 192,192 observations used to compute this average? Because there are probably NA values in this data. Okay, so report the average family income and its standard deviation in dollars. Average family income is represented by this name, family income, and we can also calculate its standard deviation. So average family income is $29.02, and the standard deviation of this uh, column or this variable is 18.73, which is very high. So most probably the range of values, we can also see the range of this. The range is very high, must be very high. See, some people are only, some families income is only 0.5, and some families are earning 65. So I think the data is in thousands of dollars. So some families are earning only 0.5 thousand dollars, and some families are earning $65,000. Since the range is high, that's why the standard deviation is also high. So now let's look at the third question. The data set is MEAP01. Press Ctrl plus Enter, and remember to detach the data set once your work has been done. Now attach this data set for the question. Now let's look at the headings of this data set. Now it's saying, the first part says the find the largest and smallest values of math 4. The function is range. Okay, some students are scoring 0 marks and some students are scoring 100 marks. Does the range make sense? I think it does not make sense, because some people are failing and some people are scoring 100% marks. So it's very, I think it's illogical. The same students in the same class are getting failed by 0 marks, and some people are able to score 100 marks. So there must be a problem. How many schools have a perfect pass rate on the math test? What percentage is this of the total sample? So for this we can use the sum function. Now we have to apply a condition of 100. See, the second part says how many schools have a perfect pass rate on the math test. So 37 schools have a perfect pass rate on the math test. And what percentage is this of the total sample? Now let's create a percent math 4. Copy the previous command, and divide this by length of math 4. .021, it means 2.1% of schools have a perfect pass rate on the math test. How many schools have math pass rates of exactly 50%? So again, copy this command and just change this value from 100 to 50. 12, only 12 schools have this 12 schools have the pass rate of 50%. Compare the average pass rates for the math and reading scores. Reading score is named by read 4. So let's type, first find the mean of math and then read 4. So yeah, average pass rate on maths test is 72.68, and on the reading scores it is 60%. Which test is harder to pass? So comparing the average values, reading test is harder to pass. Now let's find the correlation between math 4 and read 4. For this we can use the function core from the base R and just type the variable names math 4 and read 4. The correlation between these scores is 83.44%. So it's very it's a high correlation. It means that someone who is able to pass the math test is also probable to pass the reading test. The variable, now let's look at the second part. Again, the sixth part, the variable expenditure is expenditure per pupil. Find the average along with its standard deviation. The mean of expenditure per pupil is 5264 dollars, and the standard deviation is 1000. So it's comparatively high, and I'm sure in this column also the range of this data column is also very high. See, the minimum expenditure on per pupil is 1268, and the maximum expenditure is 11,957. So that's why the standard deviation is more. So yeah, we can say there is a wide variation in per pupil spending. If you like my videos, then you can subscribe to my channel, and you can also connect with me on different social media platforms. I have given this Linktree link in my description box. Now look at this seventh part. Suppose school A spends $6,000 per student and school B spends $5,500 per student. So now let's create two new values. School A expenditure is 6,000. Press Ctrl plus enter, and then type the value for school B expenditure. Type 55500, and now it says to calculate by what percentage does school A spending exceeds school B's. So we can do this by dividing by subtracting school B expenditure from school A's, and then dividing it by school B's expenditure. So school A's expenditure exceeds school B's expenditure by almost 9%. And the other part of the question is compare this to, so it says to do a log transformation of this data. So we can easily do this in RStudio by simply typing the log command. Take the log of school A expenditure and then minus log of school B expenditure, and then press Ctrl plus enter. Now it gives the result 8.70. It means that school A's expenditure is greater than school B's expenditure by 8.7%. Now this result differs due to the property of logs. Basically, we take log of data when there is skewness in the data, and for the purpose of normalizing the data we take the log transformation, and it will give a different result from normal percentage change when values are greater, when values differ greater. So we can discuss about this in some other video about log properties, and we shall continue with this exercise. Now the question 4. Now let's switch on to question 4. Question 4. Okay, remember to detach the data set. As I said earlier, it is important the data set was MAP01. Okay, so now let's move on to question 4. The data set is JTrain2. It's about job training data. Package is Wooldridge. Press Ctrl plus enter. Now attach this data set. Now let's look at the column headings of this data set. Okay, so let's see. Use the indicator variable train to determine the fraction of men receiving job training. So it means that how many men receive training, and train is an indicator variable. Therefore, the 1 values in this column indicate the participants who received job training, and the 0 values will represent those participants who did not receive training. So we want to know the number of people who received training. So that will be sum, and train equals to 185. So, and what is the total length of the column vector? It's divided by length train. So 41.5% of the participants in this sample received training. Now let's look at this. The variable RE78 is earnings from 1978 measured in thousands of dollars. Find the average from sample of men receiving job training. So we want to calculate the average of participants who received job training and who did not receive job training. So we can utilize the function from deploy package. The dataset name is jtrain2, jtrain2, and then use the pipe operator, and then we want to group by the data by train, then again use the pipe operator, and then we want to calculate the average. So we will create a column by the name of average, and uh, we want to calculate the mean average of earnings of 1978, and if there are some any values, then we should add this additional parameter na.rm equals to true. So look at this. The person who received job training, the persons who received job training has an average of $6.35 maybe per hour, and the data is in thousands of dollars, so multiply it by thousands. So the average earning for person who received job training is $6,035, and the person who did not receive job training, their average income is $4,550. Okay, so let's move on to the next question. Now look at the next part of this question. The variable un78 is an indicator of whether man is unemployed or not in 1978. So what fraction of the men who received job training are unemployed, and what about for men who did not receive job training? So now let's look at this. Now type the dataset name, again use the pipe operator, type group by. Now we have to group by two variables, two indicator variables. The first is training and the other one is unemployed 78. Now again use the pipe operator. Now type the command tally. Now we have a frequency table on the basis of these two categorical variables. The zero value in train represents who did not receive training, and unemployed 78, and the zero value in this indicates that he is not unemployed, and the one value indicates that the person is unemployed in 1978. So there are 168 persons who did not receive job training and are not employed, and 92 persons are those who did not receive job training but are unemployed. And look at this value. There are 45 persons who received job training but still are unemployed in 1978. So the difference is huge comparatively. There are almost 92 persons who are unemployed who did not receive training, and there are only 45 persons who received job training but still are unemployed. So yeah, training was effective, and yeah. So now let's move on to the next question, the fifth question. Again, remember to detach the dataset once its work has been done. Now the fifth question utilizes data set Fertile2. Press Ctrl plus Enter and attach this dataset. Let's look at the column headings of this dataset. Okay, now the variable children refers to the number of living children. The variable electric is a binary indicator equal to 1 if the woman's home has electricity and 0 if not. Find the smallest and largest values of children in the sample. What is the average of children? So it's easy, we have done this before. Type range of children. So some women do not have a child at all, and some women have 13 children at their home. And now look at this average number of children. There are 2.26 children per woman in the sample. What percentage of women have electricity in the home? So for this we have to type some command, and the electricity is named in this data set by the name of electric, and type na.rm because there are some na values in this data set, and divide this by length of the column. So 14% of women have electricity in the home in this data set. Now it says compare, now it says compute the average of children for those without electricity and do the same for those with electricity. Now type the dataset name fertile 2, group by, we are going to group this dataset by electric, and then again type the pipe operator, and then we have to use summarize, type this column name average and mean of children, and again type this na.rm equals to true because there are some na values in our dataset. Now look at this. Those women who do not have electricity at their home, the average number of children is 2.33, and the women who have electricity at their home have an average children of 1.90, so almost 2. Okay, so let's look at this next part. It says from part third, can you infer that having electricity causes women to have fewer children? So does electricity have a causal effect on number of children women have? You have to give the answer on my comment section, and I will look at your answers and evaluate them and give you the right answer in your reply. Now let's look at the next question and detach this data set once its work has been done. Now we are at question 6, and the data set for this is county murders. Now let's look at the column headings. Now let's look at the question. The variable murders is the number of murders reported in the county. The variable EXECS execution is the number of executions that took place of people sentenced to death in the given country. So let's look at this. Most states in the United States have the death penalty, but several do not. How many counties are there in the data set? Okay, but before solving the question, look at here. Use only the year 1996. So let's create a new dataset, murders 1996. From this broad dataset, type county murders, and then give a square bracket and type this condition: year must be equal to 1996. And remember to put the comma after this, and then press Ctrl plus Enter. Now we have a new dataset by the name of murders 1996. So let's detach the previous dataset first, and then we will attach this new dataset. Okay, now we can solve the problem. Now, how many counties are there in the dataset? So we can use the function from base R for this by the name of length, and then unique county ID. There are 2197 unique counties in this dataset. Now, of these, how many have zero murders? And what percentage of counties have zero executions? So for this we can use sum equals to sum murders equals to 0. There are 1051 counties which have 0 murders. And what about the executions? For executions we have, and we have to calculate the percentage, so we can divide it by length executions. There are 98.5% of the counties have 0 executions in our data set. Now let's look at the second part. What is the largest number of murders? So we can use function max for this. And what is the largest number of executions? Again, use max. Compute the average number of executions and explain why it is so small. Now let's look at the average of executions. Only 1% rate is there in the dataset. So why it is so small? You can comment about this in the comment section. Now let's look at the third part. Compute the correlation coefficient between murders and executions. Simple. Type COR from the base R, and the column names are murders and execs. The correlation between murders and execution is 20%. It is very low. And why it is so low, you can again comment in the comment section, and we will together look at this. And the fourth part says you should have computed a positive correlation. And part third, do you think that more executions cause more murders to occur? What might explain the positive correlation? We can discuss about this in the comment section. Now let's come to the seventh question. Question 7 utilizes the dataset alcohol and attach this dataset and look at the column headings of this dataset. Okay. Now it says the variables employ and abuse are both binary variables. They take on only the values 0 and 1. What percentage of the men in the sample report abusing alcohol? So the alcohol variable is given by the name of abuse, and it is here. Okay. So we have to calculate percentage divided by its length. So 9% of the men abuse alcohol. And what is the employment rate? For the employment rate, we can use the same function. 89.81% of the men are employed in this data set. Now consider the group of men who abuse alcohol, and in the next question we have to calculate what is the employment rate for the group of men who do not abuse alcohol. So there are two categorical variables, so we can utilize the function from deployer package. The dataset name is alcohol. Now type pipe operator and then write group by. We have to group by two variables. The first one is abuse and the second one is employ, and then again use the pipe operator and then use tally function. Now those who abuse alcohol are and those who are employed, the number of persons are 850, and those who abuse alcohol but are unemployed are 124, and those who abuse alcohol and those who are employed is the greatest number is there, 7,972, and those who do not abuse alcohol and are also unemployed, they are 876 people. Now look at this fourth part. Discuss the difference in your answers to parts second and third. Does this allow you to conclude that alcohol abuse causes unemployment? We can discuss about this in the comment section. Again, remember to detach the data set? Alcohol. Okay. Now the final question and the last question is here, question number 8. It utilizes the data econ math. Let's look at the column headings. Now look at the first part. For this problem, we are interested in two variables: score, which is the final course score, and econ HS, which is a binary variable indicating whether a student took an economics course in high school. How many students are in the sample? How many students report taking an economics course in high school? So for this, we can do, first of all, how many students are in the sample? For this, we can do n row. We can utilize the function n row and name this data set econ math. There are 856 students. Okay. Now for those who report, who had economics course in high school, for this we can use sum econ HS equals to 1. 317 students had economics in high school. Now find the average of score for those students who did take a high school economics class, and how does it compare with the average of score for those who did not. So again, we can utilize the function from deploy package. We have two variables to group by. First is score and the second one is econ HS, and then use again pipe operator and then use summarize and name this column as average, and we have to calculate the mean of score, and if it has NA values, then we can add a additional parameter na.rm equals to true. Okay, simply we can just group by the econ HS course. We do not have to use the score variable. Now let's run it again. Now look at this. Those students who had economics course in their high school had an average score of 72.1%, and those who did not have economics course in their high school had an average of 72.9%. So those who did not take had a higher average than those who did. Now look at the third part. Do the findings in part second necessarily tell you anything about the causal effect of taking high school economics on college course performance? Explain. We can discuss about this in the comment section. And if you want to obtain a good causal estimate of the effect of taking a high school economic course using the difference in averages, what experiment would you run? Well, we can discuss this question again in the comment section because the time is running out. It is almost 60 minutes. So we will discuss these subjective questions in the comment section. Thank you.